Welcome to INSITECT. Today we are talking about hospitality networks. Common design and deployment mistakes. We've all been there, right? You check into a hotel, you're excited to, stream a movie or maybe join a work call, and the Wi-Fi just chokes.
Instantly. It's a universal frustration.
Exactly. And it's so much more than just an inconvenience for the guest. Today, we're going deep on the critical network design failures that cause that lag, but more importantly, how they expose the entire property.
The entire operation, from mobile check-in to your room key.
Even the payment systems. This isn't just about streaming 4K video anymore. It's about the security and operational foundation of the entire hotel.
That's the core of it.
Yeah.
The network today, it's the central nervous system of a modern hotel. It's not just an amenity.
Right.
It handles everything: HVAC, phones, guest entertainment, and critically payment processing. But what our research keeps showing is this systemic struggle with slow connections.
So why is that?
It's a strategic mistake. Properties are still treating this essential infrastructure as a cost to cut, not the core asset that it actually is.
An asset that drives revenue.
And the stakes are, they're immediate. When a hotel network fails, revenue stops instantly.
Wow.
Critical systems just halt, payment terminals go offline, checking grinds to a stop.
Yeah.
And think about the door locks most our network now.
So they could fail
They
then.
can become completely unresponsive. That's a massive security nightmare that needs a fix right then and there. Reliability is just non-negotiable.
And you have to contrast that operational need with what travelers expect now.
Oh, the expectations are through the roof.
Guests aren't just looking up directions. They show up with what? A laptop, a tablet, a phone, a smartwatch.
Multiple devices per person.
And they expect it to be as good as their fiber connection at home? Or better. They want to stream in high def, run video calls, upload huge files, all without a single buffer.
Yeah, and that brings us to the numbers, which are just staggering, this challenge of device density.
Let's put some scale to it. A typical hotel, maybe 200 rooms.
Mid-sized, yeah.
At full capacity, you could have 600 guests, and those 600 people are running, maybe 1,500 devices at the same time.
At least. It creates this chaotic, unpredictable, just relentless demand for bandwidth. It's a uniquely stressful environment for a network.
And that stress leads right into what is probably the biggest, most self-defeating financial mistake we see.
Capacity planning.
Exactly. It's planning based on optimism, not reality.
It's a huge issue. Research consistently shows that properties buy their internet circuits based on low season numbers.
So they plan for 40% occupancy?
40%, sure, it cuts costs on paper, but what happens when a big convention books the place out and you hit 100%?
The whole system just collapses.
It's a guaranteed bottleneck.
Yeah.
And you can put numbers on it. One guest streaming a 4K movie needs, say, 25 megabits per second.
Okay.
Their partner is uploading high-res photos, that's another 15. A colleague on a video call needs a stable 10. If the hotel only got half the bandwidth they actually need.
Then every single IT ticket is just a symptom of that one bad decision.
You can't fix bad infrastructure with a help desk ticket. Insufficient bandwidth is the root cause.
And it's not just the internet pipe coming into the building, is it? It's the infrastructure inside that's, decaying.
Absolutely. During renovations, especially the cost-conscious ones, there's a huge temptation to just leave the old cabling and switches in place.
They figure, hey, it still works.
It might pass basic data, yeah, but it's missing two critical things for any modern hotel.
The first one has to be power.
Power. PoE power over Ethernet. Modern Wi-Fi, 6 access points, your VoIP phones, your digital door locks, they all need significant, clean power delivered over that network cable.
And if the old switch can't provide it?
The brand new, expensive access point you just bought runs in a crippled, low-power mode. Or it just won't work at all.
So that's one. What's the second missing piece?
Modern features, specifically logical segmentation. We're talking about VLANs, virtual local area networks.
Which are absolutely essential for security.
Foundational. Without the ability to assign devices to their own walled-off segment, you end up with a flat network. It makes real security and troubleshooting basically impossible.
You're building a new hotel on a foundation from 20 years ago?
Exactly. And that leads right into this headache of device sprawl we mentioned.
The old designs assumed, one laptop per room, maybe two?
And probably a wired connection. Now, a 100-room property might have 400, 500, even 600 active connections at once. And here's the hidden part.
The background traffic.
The background chatter. These devices are never silent. They're constantly syncing email, doing app updates, cloud backups, and that's before you even add the hotel's own IoT devices.
Smart thermostats, connected locks, lighting systems.
All of it. This constant traffic load just pushes us toward the big question.
Is any of this secure?
Right. When we shift from performance to security, the most dangerous flaw we find is just inadequate separation.
You mean segmentation?
A total lack of it? We see properties putting guest Wi-Fi, staff devices, and even the mission-critical payment terminals all on the exact same network.
That sounds incredibly risky. You're creating a direct attack path.
That's precisely what it is. You have a guest device, it's untrusted by definition, maybe it's already compromised, and it's sitting on the same network segment as the PCI-compliant payment system.
So that guest device can, in theory, see and talk to the point-of-sale terminal.
It's not theoretical, it's a direct, immediate vulnerability just waiting for someone to find it.
So what's the fix? What are the layers that have to be there?
The isolation layers have to be non-negotiable. It starts with those VLANs we talked about, policed by a proper firewall.
So layer 1, guest Wi-Fi is completely separate.
Completely isolated in its own dedicated segment. Layer 2, staff wireless gets its own highly secured network.
And payment system.
That's layer 3. They need to be so isolated they're practically air-gapped from all other traffic.
Yeah.
This kind of rigorous segregation isn't a luxury, it's basic risk management.
And then there's the authentication problem, which is just as glaring.
Especially on the guest portal. So many just ask for an email address.
Which gives you zero identity assurance.
None. A much stronger approach is something like two-factor SMS verification, something that provides some accountability.
What's interesting is the gap I see between wireless and wired security.
Well, it's a huge inconsistency.
A property might have strong authentication on their Wi-Fi, but then you find an open, active Ethernet port in a meeting room.
Or behind the VoIP phone in the guest room.
Right.
An attacker can just plug right in, bypassing all the wireless controls and landing straight on the internal network.
So port security has to be consistent everywhere.
Every single physical interface. For guests, for staff, for the security cameras, all of it.
Okay, let's switch gears to something every single traveler has felt. The weak Wi-Fi signal. The dreaded 1 bar.
The RF problem. Radio frequency planning. Or, more often, the lack of it.
And research shows this usually comes from a really outdated practice.
Putting the access points in the hallway. It was a budget decision.
But it just doesn't work with modern devices, does it?
Not at all. When the AP is in the corridor, you're forcing the weak little radio in your smartphone to shout through 2, maybe 3 walls, plus all the furniture.
It's just not designed for that.
It's an impossible task. It leads to dropped connections, constant retries. The only real solution is in-room placement. Get the access point close to the devices.
And there's a really counterintuitive technical detail here that so many installers get wrong.
Transmit power.
They just crank it up to the max, right? Thinking more power equals better coverage.
It's a classic mistake.
Mm.
In a dense environment like a hotel, maximizing the power just creates this massive, noisy overlap. It's too much interference.
It's like everyone in a small room shouting at the same time.
Exactly. You can't hear anything clearly. Proper RF design actually uses controlled, lower power levels. It creates smaller, cleaner coverage cells.
So your phone only hears the closest, clearest signal.
That's the goal. But it requires real expertise, and that's often the first thing cut from the budget.
We also can't forget about just physical stuff getting in the way.
Physical interference, yeah. Planners overlook it all the time. You have the obvious things like interference from a neighbor's Wi-Fi in a dense city.
But inside the building, you have materials like low-E glass in the windows.
Which is great for energy efficiency, but it acts like a mirror for Wi-Fi signals, bouncing them all over the place.
Mm-hmm.
Or metal studs in the walls creating dead spots.
Even the interior design can cause problems.
Oh, absolutely. A big decorative metal screen, a large mirror. That mirror causes something we call multipath interference.
Explain that.
Think of the signal bouncing off that shiny surface like a pinball. Your phone gets multiple copies of the same signal, but they arrive at slightly different times.
And the device struggles to piece it all together.
And that's what causes that choppy, jittery video call or the connection that keeps dropping. The physical room is part of the network design.
Let's talk about resilience, the ability for the network to actually survive a problem.
A huge, huge weakness in most designs. They are full of single points of failure.
So, for example, if one core switch that powers an entire floor goes down...
That's it. You've wiped out guest services, staff phones, and door locks for 100 rooms. Or a single internet outage takes the whole property offline.
It's too fragile.
A resilient design is mandatory. You need redundant core switches with automatic failover, so if one dies, traffic just hops to the healthy one.
And multiple internet connections?
Diverse internet circuits, coming in from different physical paths, so if a backhoe cuts one fiber line, the property stays online with the other one.
And once you have that physical resilience, you need operational resilience. That brings us to quality of service, or QoS.
If you're running a network without QoS, you're basically leaving your business operations up to chance.
To the whims of the guests.
Absolutely. Think about it. A couple of guests start downloading massive video games. That bulk traffic can just swallow 90% of your total bandwidth.
And suddenly the payment terminal at the bar times out.
Or the really important video conference freezes mid-sentence for a convention booker.
So QoS is like an insurance policy. It's about prioritization.
Intelligent prioritization. Voice traffic for phones gets the absolute highest priority. Video conferencing gets its own dedicated slice of bandwidth. Payment transactions get low latency guarantees.
And the general guest, Wi-Fi, the streaming and downloads, gets whatever is left over.
Exactly. It ensures the business always functions, even under peak load. You can't risk losing a major contract because a CEO's video call froze. QoS mitigates that.
The final piece here feels like a big one. Monitoring, or the lack of it.
It's a massive gap.
Yeah.
Without real-time monitoring, all your troubleshooting is just pure guesswork. Is the problem bandwidth? Is it latency? Packet loss?
You're flying blind.
You need dashboards that give you total visibility into those metrics. But the really clever systems go a step further.
They tie it into guest feedback.
Yes. They consolidate the technical health data with guest satisfaction ratings. Because sometimes a sudden spike in one-star reviews is your first and best alert that there's a major network problem.
Before the technical alarms even go off.
It transforms all that data into clear, actionable intelligence for the staff.
So when we pull this all together, what's the big takeaway? All these problems, the bad bandwidth planning, the poor AP placement, the weak security, the lack of redundancy.
They're not inevitable.
Right. Research makes it clear they are the direct result of treating the network as just a cost to be minimized instead of a strategic asset.
And if you think about the bigger picture, guests are booking their return visits based on a flawless experience. And that experience today is digital.
It's built on the network.
The goal of a modern strategic design is to ensure that your efficiency, your security, and your guest satisfaction are all built on that foundational rock of reliable, well-engineered infrastructure. That's the investment that creates a real competitive edge.
Thanks for listening. We will continue to talk about security and technology. See you in the next episode.